Okay, this is part 2 of solving equations with variables on both sides. So we still just have these last 4 examples to go through. So in these first set of examples, okay, we've got p minus 1 equals 5p plus 3p minus 8. So in this case, our first step has to be to combine the like terms. Now on my left-hand side, p minus 1, nothing combines there, and that's fine. But on the right-hand side, we have 5p plus 3p, which are like terms. So we first need to combine those together, and that gives us an 8p. Remember to carry down that minus 8. Okay, now, you're back to the same types of examples that we've had before. So you now need to decide, do you want all your variables on the left or the right? And then the same with the constants. So in this case, I chose to move my variables to the right-hand side. So I'm subtracting this initial p to the right-hand side. Okay, and again, make sure that you're lining them up with the term that they combine with. Okay, so you drop down your -1. Do not lose that sign. Remember, the sign in front of the value is connected to it. Equals 8p minus 1p is a 7p, and again, you drop down that minus 8. Now, since I moved my variables to the right-hand side, I need to move my constants to the left-hand side. So since this was minus 8, I now need to add 8 to the other side. That will allow those to cancel. So -1 plus 8 is a positive 7 equals 7p. Now, one final step, divide both sides by this 7, so p equals 1. Again, you should be going back and checking your answer. That may mean just using your calculator, and that's fine. You don't have to show your work for all of these, but you should be plugging that p value back in as 1 that you got and making sure that you get a true statement. Okay, second example here. Now in this case, we've got parentheses here. Okay, so it's going to be similar to our 2 previous examples. I first need to distribute this 2 into that parentheses. So 2 times 4x is 8x. 2 times -3 is a -6. Be very careful. There was still this minus 8 after the parentheses. Make sure you carry that down. Then 4 plus 2x gets carried down on the right side of your equal sign. Now you're going to need to combine some like terms here. Okay? -6 and minus 8. Those are constants, but they are like terms, so you need to combine them together. The 8x just gets carried down. -6 minus 8 is a -14. Equals 4 plus 2x, again, just gets carried down. There was nothing to combine there. Now you're back to the same previous steps. You need to decide, do you want your variables on the left or the right-hand side? So in this case, I chose to move my variables to the left-hand side. That meant this positive 2x needed to get subtracted. Again, you're always using the inverse operation. So I subtract 2x from both sides. On my left, I get 8x minus 2x is 6x. Carry down this 14 equals, and then carry down your 4. Now, since I moved my variables to the left, I now need to move my constants to the right-hand side. So I'm going to add this -14. I'm going to add it to the other side. When I do that, I bring down my 6x. 4 plus 14 on the right side gives you 18. Now your final step, you're going to divide by this coefficient of x, which is a 6. You're going to divide both sides by 6, which gives you an answer of x equals 3. Okay, 2 more examples, and these are what we call our special situations. Okay? They're only called that because of the type of answer that you're going to get. The work will be exactly the same as what we've done in all the previous examples. Okay? So in this first one, 9d plus 12 equals, and I have 9 parentheses d plus 3. So this looks very similar to our previous examples. I start by distributing this 9 into my parentheses. So my left-hand side stays the same, 9d plus 12 equals 9 times d is 9d, 9 times 3 is 27. Okay, now I'm going to have to decide if I want to move my variables to the left or the right. I'm choosing to move technically either of them. Okay, so if I subtract this 9d and I'm moving it to the left, so this original 9d needs subtracted, so I subtract it from both sides. Now, if you notice, these are both at 9D, so it cancels on both sides. This was a positive 9 minus 9. That's 0, so that cancels. And on my right side, 9 minus 9 is 0, so they both cancel. Now, at this point, you need to continue to carry down the constants that are left over because you have a decision to make. So you carry down the 12, and you also carry down your 27. Now you need to look at this statement and decide, is this true or false? Is 12 really equal to 27? And it's not. So that's why we put the slash through the equal sign. That means that 12 does not equal 27. Okay, because this statement is false, your answer is no solution. Okay, that means that there is no number in the world that you could type in or you could fill in for D in this entire equation and end up with a true solution. Okay? It is not possible. So it's no solution is your final answer. Now in the second example, again, we start by distributing in this case because I have parentheses. So 3 times 2a gives me 6a. 3 times 2 gives me 6. On the right-hand side, 2 times 3a is 6a. 2 times 3 is 6. Now again, you have to move your variables, so I'm going to choose to subtract this 6x to the other side. When I do that, the same thing happens as the previous example. Okay, 6a minus 6a is 0. They cancel. Those ones are gone. So I carry down my 6. On the right-hand side, same thing. 6a minus 6a is 0. They both have canceled. So I carry down that 6 as well. Now again, you have to decide, is this statement true or false? 6 equals 6 is a true statement. Okay, so because this is a true statement, your equation has an infinite amount of solutions. Okay, that means that all real numbers, so any real number that you put in for A will make this equation true. Okay, so your final answer then is all real numbers. So for the special situations, you have two choices. Either you get a false statement and your answer is no solution, or you get a true statement and your answer is all real numbers. Okay, so again, this was solving equations with variables on both sides, and this was part 2 of the notes. And this is your concept number 8. My bad, it was not concept number 8, this is concept number 7, but this is part 2 of concept number 7.